What are we going to say about engineering? Well, Clive held out an iPhone. That's something that most of us have. You might be an Android geek, I don't mind, it's fine. But I think everyone in this room has a mobile. Anybody who doesn't own a mobile here? Okay, so engineering is absolutely ubiquitously part of our lives today. And if you're not an engineer, you're certainly a user of engineering. What the users of engineering might not know is that engineers have all the fun. It's actually the best thing in the world to be an engineer, and I'm going to tell you why today. So, I'm going to tell you a little bit about what is engineering, and on the off chance that there are people here today who don't know what engineering is, but I promise I won't spend a lot of time. I'll also talk a little bit about engineering opportunities. I think just taking a glance around here that most people are prospective students, but there might be a couple of parents in the audience, and parents are always much more concerned about job opportunities than the people who are actually going to study. And finally, I'm going to tell you why you should be doing engineering at Macquarie and nowhere else. So, first thing we have to do is we have to think big when you do engineering. That's Concorde. We didn't design it here. Okay? Concorde has been around since the 1960s and it was taken out of service in 2003. But it's a fabulous example of a massive engineering project. Engineering projects are carried out by people in teams, and when you look at Concorde, and incidentally it's not a great photograph because it's really hard to get a picture of Concorde with the nose straight and not pointing down for takeoff and landing, so apologies for that. So, you need a bunch of electrical engineers. You need people to do the electronics. There are end control systems that need to be implemented. Clive actually showed you a really nice pic of the 1903 flight of the Wright Flyer. Didn't spend much time on the pic, but I'm going to tell you something about it because I was lucky enough to actually have a little piece of the Wright Flyer engine block I could put in the microscope. It was very cool. So, the Wright Flyer involved the pilot lying inside the Wright Flyer and moving some lines that were attached to the wings, which were flexible because they were made of canvas, moving his hips around to flex the wings. And we don't flex wings anymore in aircraft, but that was the direct forerunner of the ailerons that you see on every aircraft that flies today. So, lots of things happening in the Concorde: mechanical engineering, mechatronic engineering, wireless engineering. It's all a big engineering project that couldn't be done without a whole lot of engineers in a big team. Something that we shouldn't forget to do is to think small. Also do engineering at a very, very fine scale. And I wanted to show you this picture because this is some engineering that's done at Macquarie. This is done in my research group. And the first thing you should see is the scale bar. I think looking around that you probably all know that a nanometer is 1,000 millionth of a meter, which is to say it's a millionth of a millimeter, which is something that's about so big. So 2 nanometers is really small. And we should be thinking on that scale because engineering is going to that end of the spectrum. Engineering is absolutely going to a very fine scale. This is not my picture. This is from Stanford University. It's a small machine. I don't know if you can see that very well. Small machine on the right, red blood cell on the left. Now, a red blood cell is about 7 microns across. A micron is 10 to the minus 6 meters. So it's really very small, but it's entirely possible to start to engineer things at the same scale as a blood cell. And that is a huge research effort in engineering at Macquarie and indeed all over the world. So if you want to get involved in that, this is the place to do it. Okay, so the simple question, what is engineering? Engineering is a whole bunch of stuff. It's not as simple as it sounds. So I'm just going to take you through what engineering is. That's a fairly common sort of engineering drawing for a large structure. You might be designing an automobile, you might be designing something smaller. But what I really want to show you is that this looks like a linear process. You design something, you imagine it, you draw it, you scale it, you get the dimensions right, and so on and so forth. Then you manufacture it. When you've manufactured it, you put it into service. Obviously, you need to maintain it. And hopefully you won't have to do a failure analysis, but most things break, let's face it. If it doesn't fail, well, you're going to need to go through some kind of a recycling process. That's the picture in most people's minds of engineering. It's not incorrect, but it is oversimplified. Because when we design something, we design it for purpose. We design it for what we're looking for, but we also have to design it with maintenance in mind. It's not good designing something that you can't maintain, because then you have to throw it away the first time something goes wrong. And of course, when you design, you have to take manufacturing into account as well, so low cost. Remember, low cost is really important. Cost is probably the most important engineering property on the planet. Remember that when you become engineers. So you have to design for manufacture and maintenance, and you have to maintain for design and manufacture. You have to maintain for a lifetime. And you need to think about design when you think about maintenance. And your failure analysis improves your understanding. Really important. You should never design without thinking about how something might fail, because you have to design against failure. Otherwise, you'll have a wonderful design that just falls apart. So you need to have a good understanding, and of course your failure analysis needs to feed back into how you manufacture, which may of course decide how you design, and so on and so forth. The point I'm making, it's not a linear process. It's incredibly complicated. You cannot do one thing at a time because you're going to get it wrong. So engineering is quite a special discipline. It requires people who can think of many things at once. It requires people who think laterally. If you're good at that, engineering is what you'll be good at. So, what's an engineer? First of all, an engineer is hands-on. Absolutely, it is a hands-on profession. You cannot be a designer, you cannot be a manufacturer, a maintainer, a failure analyst just by sitting and thinking. You have to get involved. You have to get your hands dirty. You have to be a problem solver. And in our undergraduate and postgraduate work, we spend a lot of time learning to solve problems. I'm just going to step back for a moment and say I'm completely, tragically upset to say that I have probably got more students who've gone into the banking industry after a PhD with me than into engineering, because the banking industry just steals all the engineers because they're great problem solvers. We do. You need to be a creative thinker. You need to think outside of the box to get the solutions right so that you don't end up with a failure. You need to be resourceful, and something that's really important, an engineer has to be a consummate professional. So it's not simple. It's not simple, but it's a lot of fun. So career opportunities. If there are any people who are concerned about career opportunities in the audience, this is the moment. We don't have nearly enough engineers. Australia produces about a third as many engineers as we need. So this is a great place and a great time to become an engineer. And I tried to list the career opportunities, but they're just way too many. I'll read some of them. You could do mobile telephony, you could do manufacturing, you could do mechanical engineering, product design, da-da-da-da. Okay, there's a bazillion things you can do with an engineering degree. I would recommend that you don't over-specialize. I'm not entirely convinced that an engineering degree in virtual widget design for something or other is a perfect thing to do. Do a fairly straightforward engineering degree, because those of you who do an engineering degree are going to be engineers for 50 years. The widgets that you learn about, if you do an over-specialized degree, may not still be around in 30 years' time. Learn the basics, and you will change through your lifetime. So there are plenty of career opportunities out there. I went and had a look at the jobs website. Seek is the one that has a lot, and they have a nice search function. I just put the word engineering in this morning and came up with 12,000. 12,000 jobs looking for some sort of engineer. We really are short of engineers. So if there are any parents in the audience Your kids will support you, right? If there are any future engineers in the audience, you're going to have a lot of fun. And you can support mum and dad as well, it's fine. So, okay, so engineering degrees at Macquarie, what do we actually produce? Well, we have one engineering degree, the Bachelor of Engineering, but you can be different types of engineer inside of that. Before I go on to the individual types, I need to tell you that our engineering degrees are accredited by Engineers Australia. It's hugely important. Engineers Australia is a signatory to the Washington Accord. The Washington Accord oversees engineering across most countries on this globe and an increasing number. What this means is that the engineering degree that you get right here at Macquarie is going to be fine in Seattle. It will shortly be fine in Beijing. It will be fine in London. It will be fine anywhere. You can use your engineering degree no matter where you travel. So, you can do electronics engineering with your Bachelor of Engineering from Macquarie, computer engineering, mechanical engineering, it's me, Professor of Mechanical Engineering, mechatronic engineering, which is kind of a mixture of all of the above, software engineering, which is key to all of the above, and telecommunications engineering, that comes back to, amongst other things, the mobile phone in your pocket. So we produce many different types of engineer here. We said up front, we don't produce civil engineers, we don't produce chemical engineers. We don't go for large structures, so we don't do civil engineering, we do not design bridges, but we probably design the systems that you put into a bridge that tell you when it's going to fall down. This is quite important. Okay, so let somebody else build the bridge, but we'll tell you when it's going to fall down. Chemical engineering, we don't produce on an industrial scale chemicals that are necessary. They are indeed very necessary, but we probably design the automation system, the factory system, the turnkey system that is used to produce those. So those are two areas that we don't touch, but what we do overlaps with everything. If you have tons of energy, you can do your engineering degree along with another degree. You can do a double degree with arts, commerce, or science. So, if anybody doesn't have enough to do, that's what you should do. Lots of stuff. Okay, so what did we do when we put these engineering degrees together? The first thing we did was we went out to ask a lot of questions of a lot of people. Number one, we asked employers what they want. And they said some interesting things. I did this myself when I came to Macquarie. The first thing I did was we go and talk to industry. And of course they said, you've got to have a good grounding in science. Well, at Macquarie, that's a given. You're going to get a good grounding in science. You've got to have a good grounding in the engineering that we offer. Fair enough, but also fairly obvious. What was interesting was they almost all talked about communication skills. Oh, please give us engineers with good communication skills and good teamwork skills and good practical skills. You don't necessarily get those with every engineering degree, but you will get them here at Macquarie because we believe that they are important. And we know that they're important to employers. We also, just not to rely too much on just what employers want, they ask engineers be ready for the future, which is something we think you should want too. You don't just want to be qualified for the 5 years after your graduation. You want to be an engineer for the rest of your life doing really cool stuff, which means you have to learn how to learn on the basics, pick up new things quickly, be an early adopter. If you're ticking all these boxes, this is what you should be doing. Okay, local industry and Macquarie Engineering, Clive mentioned that. I'm not going to say too much about it, except that when I started to collect the logos, they just got too busy and overwhelmed the overhead slides. So we are connected with a lot of local industries who sit on our advisory committee, offer scholarships. Oh, I'm sorry, let's go back there. Come back there. Yeah, there we are. We connect with the industry in a number of ways, and we continuously engage with them. So anyone who does engineering at Macquarie is involved with industry. It's part of our degree as well. We ask students what they want, and students want what students want. It's pretty much the same across all degrees. They want an internationally accredited degree. Industry exposure, got that, no problem. Scholarships, Macquarie is very generous with scholarships. Good access to academic staff. I want to stop there for a moment because it was something that was fairly new to me when I came to Macquarie. It's really great. Students are extremely engaged. People walk in and out of my office all the time, stop me in the corridor, chat to me about this and that. It's wonderful. It is truly a community of scholars from the most junior to the most senior. Practical experience, I'll be telling you something about that in a moment. And this is also something that's important to me, an atmosphere of collaboration. I was told by someone who graduated from Macquarie that it was about collaboration, not a competitive environment. And I think that's a nice way of putting it. It's about connecting and collaborating rather than about competing. So that's what we got from the students. Moving along to the Macquarie engineering experience, we accordingly offer an internationally accredited degree, a whole lot of engineering options, very practical skills that you can use when you go into industry, good facilities, Clive has showed you some of those, close interaction with the staff, industry exposure, and my personal favorite, the last one, fun. If we're not having fun, what are we doing? So we do this because it's really fun to do, not for any other reason. Okay, so looking at the Bachelor of Engineering, I just want to tell you a little bit about year one because it's common to all engineering degrees, so no matter what you do at Macquarie, this is what happens in year one. Computer science, absolutely fundamental to engineering. Mathematics, if you can't do the maths, you probably shouldn't be doing engineering at a university. There's plentiful support offered, but you absolutely have to get the maths and you absolutely have to get the physics. That's the scientific foundation. There are 2 units that we teach, Introduction to Engineering. That's the start of a series of professional units, how to become an engineer because it's a professional degree. Electromechanics, it sounds like an odd title, but it covers all the sorts of engineering that we offer. That's why it's a year one common course. Everybody does it. When you get into second year, you specialize. You decide, I want to be an electronics engineer, a mechanical engineer, or whatever. Year one is common. That's when we bed down all of the basics. And we do practical training. And this is something that I personally think is very important. Nobody should walk out of Macquarie with an engineering degree who doesn't have at their fingertips some practical skills. We've started the practical skills this year. First year students did some skills which I personally think are very important, turning something on a lathe, using a milling machine, using a drill press, and so on and so forth. And next year we're going to add some more. So I don't know if you can see that very nicely. That's the Meadowbank TAFE. And if you can squint your eyes and see any students in that, I can't see any students in that. But anyway, that's our first year engineering class this year. They went and spent some time at the TAFE, put together a course specially for them so that they could learn those skills. And they came back with some quite cool things which they had made in the course and so on. So we're now able to rely on the fact that these people now have the skills to move forward. And you can talk to some of them in E6A. We've got some young engineering students there who have acquired exactly these skills. Okay, the year 4 is also fairly similar across all engineering degrees, so I'm kind of skipping over years 2 and 3, which are more specialized. In year 4, depending on what you've chosen, you're going to do advanced engineering. So you might do advanced mechanical engineering, advanced electronic engineering, and so on and so forth. So that's what the X's are all about. You do advanced engineering, systems design and engineering, because that applies to everything. Principles and practice applies to everything. Industry experience applies to everything. And a major research project which will take half a year. That's what fourth-year engineers do. And those engineering projects are massively important and might be done with an industry partner if you so desire. So, I thought that, sorry about that, I might show you the sort of problem that our engineers are able to solve. I'm not going to spend a lot of time on it, except to say, I don't know if I'm allowed to show this picture, because it's not mine. Person taking the movie, this is not my picture. What if you had a spherical pressure vessel, and you were cycling it up and down in terms of pressure? How thick would you make the wall? So that's manufacturing. What would be the lowest cost? That's keeping your boss happy. Can you use a leak before break design? Is it reasonable? How often should you inspect? Critically important, you have to maintain, and so on. So these are real-world practical problems that anyone who does an engineering degree at Macquarie will be able to resolve. So, I'm just going to tell you what you should do for the rest of the day. Who should you visit? So, you should definitely go down to E6A. If you haven't been there already, go down to E6A. We've got 3 or 4 robotics demonstrations, including FIRST, which is our Macquarie-sponsored high school robotics teams, are out there in their yellow t-shirts, not black t-shirts, yellow t-shirts. On the right there, you'll see a little robot. It's a commercially available robot, RoboSapiens. It's kind of cool. It's designed to be hackable. It's a lot of fun to play with, and it is what most people have in mind when they think of robots. Industrial sort of robots don't look like that at all, actually, but it's kind of fun to have. Bottom left, there's a 3D printer, which starts with a spool of a polymeric material and builds up some sort of a design additively as we go. You should go and have a look at that happening. You can also get some little widgets, which we printed off to hand out. And you should also visit the land speed record team. Bottom right here, they are in the foyer of E6A. Last thing, you should go up and drive a Segway, because it's really cool. Does anybody have a pen? Put the pen on your finger, see if you can balance it. That's the classic control problem. It's called an inverted pendulum. You can draw the vectors like that on the left if you wish, or you can just go to a place where the problem has been solved. That's the Segway two-wheeler, which does not fall over, unless you are, well, let's not go there, in the library forecourt. So if you haven't visited there already, go and have a ride in a Segway and think about the control problem of an inverted pendulum. You're all obviously going to do engineering at Macquarie, so go line up now in E7B and get some advice on your Macquarie engineering degree. That's the other thing that's happening today. And I just guess I should finish with an invitation to do engineering at Macquarie. Get that strong foundation with hands-on practical training. Come and do it right here, where everything's happening. And engineer the future. That's it. I'm out of time. Thank you.